Hello. We are doing binomial theorems, and in binomial theorems now we come across with the Pascal triangle. So Pascal triangle is the further extension of the binomial theorem, where we find the coefficient of the series. So this is an example. So find the expansion x plus y power 4. So we use the formula what we have derived from here. This is binomial theorem Pascal. So this is here a plus b4. This is the equation. So this is a coefficient. We want to find the coefficient. So this is Pascal. So how we do it? X plus y power 4 like when we start, the first power is x4, then this is the coefficient c14. This is a permutation factorial c14. Then the power of x, the first term is decreasing 3, and the power of second term is starting. In the first term there is no y, but here we have y and coefficient. So coefficient C14 means 4 factorial or 1 permutation. It's also called permutation. So this is the third term C24. Here the x cube, in the third term it is x square. Its x is decreasing like a, but y is also square. Y is increasing. And then in the fourth term C3, C4, this is coefficient. X is only 1, y is cube, power of y, second term is increasing. And then C14, x is 0, is 1, and y is 4. So that's how we can save time, in spite of doing x plus y whole square and then whole square and then multiplying one with another one and cutting. So this is how the Pascal triangle, it's make it easy to find the coefficient. And further now x4. So this C14 mean 4 factorial into 4 minus 1 factorial into 4 factorial, like this. In the last video I did x cube y, this same is C2, 4 factorial 4 minus 2 factorial divided by, this is a formula and equation for the expansion x square y square, then for the third term and fourth term. So x4, 4 factorial 1 factorial, 4 minus 1 is 3 factorial x cube y, and there is 4 factorial, 4 minus 2 is 2 factorial 2 factorial, 4 minus 3 is 1 factorial and 3 factorial. So this is 4 factorial. So when you do the calculation, if we have this, so this mean it's include 1, 2, 3, 4. All the numbers below 4, not above. This is called factorial. Factorials. So it's similar what we do here. So it's cross, and at the end we got this one, x plus y whole square. So x4 plus 4x square y plus 2x square y square plus 4y cube, 24y 4. So this is Pascal triangle. So if you do this by a traditional method, so it will be very long. But if you use the Pascal triangle of coefficient formula, so you can easily do for certain values of n, not for all but for certain values of n natural number, you can do it. So here is binomial theorem, Pascal triangle benefits of the binomial theorem with the Pascal. So we can easily find coefficient in shallow expression by it's called Pascal triangle. Another thing, one is sequence. In sequence we just make like 1 2 3 4 5 6 7, just we arrange digit, number, letters or anything. That's called sequence. There is some some pattern we got in the sequence, that's called sequence. Another one is a series. In series we do like 1 plus 2 plus 3 plus 4, and then we establish a formula. So sequence and series, all these binomial theorems, is first purpose is for the expansion of the expression. Second is to find the counting methods. There are in statistics and mathematics and engineering where we can establish an equation or formula for our big counting system. So that's type of permutation and progression and sequence and series and binomial theorem and triangle, Pascal triangle, all these things make it easy in a big system to do the calculation and counting and other engineering method easy, or to like induction, binomial induction, where we can check the outcome of big operation. We sometimes put the value 1, then we put the 2. So sometimes it's true power 1 but not 2 power 2. So it's a kind of expansion and progression. All these terms are used. So the Pascal also did. So when you put in the binomial theorem a plus b 0, this is equal to 1. A plus b, if n is 1, so we got a plus b. When n is 2, we got this. When n is 3, we got this. When n is 4, we got this. And then here they make this triangle. From first they took the 1. When n is 1, we got 2. When n is 2, we got this. When n is 3, we got this. When n is 4. So after 6, then it's again come to 0 or something, like it's a back expansion. So this is called Pascal triangle. It's very important. This is binomial theorem, and once again a plus b power n. So a plus b is equal to binomial. It's 2 binomial. N is equal to power, n is positive integer, a and b is real number theorem. This is, if you are interested, so real number is the union of rational and irrational number. Irrational number come like under root or something, and positive integer 1, 2, 3, 0, these are come rational numbers. So the natural number also come in R. So this is a plus bn is for the real number, and this is the expansion n0, an, and the b0 here, a is n. In the second term n1, a is n minus 1, a is decreasing and b is increasing, b1. In the third term, a is n minus 2, but b square, b is increasing. Similarly, this is the general term. I have a video to find the general term if you check it. So this is come in exam almost these things. And this is n by n a0. So at the end, a plus bn. So this is the general presentation of binomial theory, where I is equal to 1 into n, n I, a n minus 1, b I. Sometime n0 in a expression like this, a n b n. So this is equal to n factorial n minus 0. This is 0. If there is another r digits, a number, so you can put n minus 0 factorial and n factorial. This one. So if we put n is equal to 1 in this, 1, 1, 1, so we got 1. And when we put here, and b0, b power 0 is 1, a power 0 is also 1, so we got an here. So this is binomial theorem, and I hope you got the idea, and thank you.